Hello, boys and girls. It's Mr. Giomini again. I forgot to tell you. Did I tell you guys I'm at Kalahari? I'm supposed to be presenting, but right now I'm, just hanging out at the wave pool. Just working hard, guys. No, actually, I am presenting today and going to different classes, so I'm really excited. Hopefully, I can bring something back to school and become a more effective teacher for you guys. So I will not be in the pool. I do not really enjoy that kind of stuff. I'm too old and grumpy for that. Any event. So we just did some multiplying of exponents. Now we're going to divide some exponents. I'm going to start you off with an example here and see if you could take a look and figure out what's going on here. So we're going to start with 5 to the 5th power divided by 5 to the 3rd. Now, notice this is just an expanded form here. We're going to take that 5 times 5 times 5 times 5 times 5, which is 5 to the 5th power, divided by 5 times 5 times 5, which is 5 to the 3rd. Now what happens here is you notice these 5s essentially cancel out. 5 divided by 5, 5 divided by 5, 5 divided by 5. So I'm really left is these two 5s, or 5 times 5 equals 5 squared. Now, can you see a relationship between what was going on between the exponents here? Just like the last one we did, there was a relationship that when the bases were the same, we could do something with the exponents, some type of operation. So if I take a look, dividing powers the same base. To divide powers the same with the same base, and again, here's a key word, boys and girls, it has to be the same base. Same base. Keep the base and subtract, we're going to subtract the exponents. So numerically it looks like this, 6 to the 9th divided by 6 to the 4th. Bases are the same. Then I just look at the exponents and I subtract them. Algebraically, b to the m divided by b to the n, bases are the same. I'm sorry, bases are the same, exponents are different, so I just subtract. All right, so let's look at a couple of examples here. Divide the product, write the product as 1 power. So first thing I notice is I see the bases are the same, which is great. Now all I'm going to do, I can write it out long form, so this really means 7 times 7 times 7 times 7 times 7 divided by 7 times 7 times 7. Again, 7 divided by 7 cancels out, 7 divided by 7 cancels out, 7 divided by 7 cancels out, so I'm left with 7 times 7, which is equal to 7 squared. If they ask you to evaluate that, then we know that would equal 49. So let's take a look. Subtract exponents, and I can do that because the bases are the same. I get 7 raised to the 5th minus 3, that's 7 squared. All right, take a look at the next one. X to the 10th divided by x to the 9th. I notice the bases are the same. So now all I'm going to do is subtract exponents. So I have x, and then that becomes 10 minus 9, which is x to the 1st power, which is just x. All right, let's take a look at another one. Divide, write the product as 1 power. So we're dividing, that's our verb. We're then going to write the product as 1 power. Okay, first thing I notice, bases are the same. So I then just subtract exponents. So we have 9 to the 9 minus 2. Well, 9 minus 2 is 7, so we have 9 to the 7th. Next one, e to the 10th divided by e to the 5th. I notice that bases are the same. So now I just subtract exponents. I have e is then 10 to the 5th. Okay, what I will, when the numerator and denominator have the same base and exponent, subtracting exponents results in a 0 exponent. So when the numerator and denominator have the same base and exponent, it results in a 0 exponent. Let's take a look. And then we know anything to the 0 power is equal to 1. All right. This result can be confirmed by writing out the factors. So you take a look. Notice everything cancels out, so you're just left with 1 over 1, which equals 1. So that's kind of why it explains that why 4 to the 0 power, anything to the 0 power does indeed equal 1. 0 to 0 power does not exist because 0 to 0 power represents a quotient of the form 0 over n over 0 to n. But the denominator of this quotient is 0, which is impossible since you cannot divide by 0. Alright. So let's take a look here. Now, the 0 power. The 0 power of any number except 0 equals 1. Okay, so we notice any of this 0 power except when it's 0 is equal to 1. Okay, now a light year, or the distance light travels in 1 year, is almost 10 to the 18th centimeters. To convert this number to kilometers, you must divide by 10 to the 5th. How many kilometers or kilometers is in a light year? Okay, I'm going to pause this. I want you guys to discuss this and see about where you would go with this problem. Okay? Go ahead and hit pause. Okay, let's take a look at how you solve this one. First thing I did, it says a light year, or the distance light travels in 1 year, is almost 10 to the 18th centimeters. Sorry. To convert this number to kilometers, you must divide by 10 to the 5th. So I notice I have 10 to the 18th, 10 to the 5th. I must divide that somehow. See, bases are the same. So if the bases are the same, what am I going to do? Subtract exponents. Excellent. So that gives me 10 to the 13th power. So light year is almost 10 to the 13th power kilometers. That is a very, very, very far distance. Go ahead and take a look at this one. A ship has 10 to the 7th kilograms of grain loaded into its cargo. A metric ton is 10 to the 3rd kilograms. How many metric tons of grain were loaded? Okay, we're going to put pause, discuss this with the young lady or young boy you're working with earlier, and see if you guys can't come up with the answer before we resume this video. Alright, you should be back. So we have 10 to the 7th divided by 10 to the 3rd. How many times does this go into this? Bases are the same, so we just divide by subtracting the exponents, and you have 10 to the 4th. Okay, you guys are responsible for this. I would like for the substitute to collect these. You are responsible for these 5 questions. Do it on a scrap piece of paper, please. Young ladies, want you to get a piece free first, and then boys, you can grab a piece. Please make sure your name is on this. Make sure you put the period as well, just in case something gets caught together. So 2nd and 4th period, you're responsible for that. All right. Hope this worked out well for you. Have a great day, and I will talk to you guys Monday. See ya.